Hi and welcome to this next clip along in this organic chemistry series. In this clip we're going to start looking at the alcohol family of compounds. So if you remember in some of the previous ones we have looked at a number of families already, and we looked at the alkanes whereby we had saturated hydrocarbons, for example, methane in this example. And we then started to look at situations whereby the molecules became unsaturated, this one being ethene, and so the alkene family of compounds. And in this clip we're going to look at the next series of compounds, these being the alcohols. And they follow a similar type of naming structure to the alkanes and the alkenes, in that this has two carbons, and so we had, if you remember, ethane and ethene we'd had in previous examples. And this one follows a similar naming style in that eth will come to the beginning of the name, and the ending of the name will be ethanol. So we get this ol ending, signifying that, like the alcohol family, that it is one of these alcohols. And the functional group motif in here is this OH group in the compound. So when we had the alkenes, if you remember, we had this double bond motif, and in the alcohols we have these OH motifs here. And so we get the naming from both the number of carbons, as we did in the other families, and the ending of the name here starts to indicate that we get this OH. And this one is ethanol. This is the type of stuff you would obviously see in beverages and also in certain biofuels. So what we need to do in this one is look at the ways in which we can manufacture alcohols, and there are two primary ways we can do that. One is via an industrial process called hydration, and the second one is via a process called fermentation, which you may have seen before in biology. And so hydration, or a methodology called direct hydration, essentially takes a alkene or an alkene, so we'll take ethene in this example, and it takes a water molecule, and through an industrial process whereby the water is steam, and we do this at a high temperature, typically 300 degrees Celsius, so very hot, and we'd also do this at a high pressure as well, so we'd squash all this stuff together under a high pressure and a high temperature. And what we would do is we'd get the water molecule to react with the ethene and create our alcohol product at the end of the reaction, and that would be a direct hydration method. The other way we could do it is by taking fermentation. And so fermentation would take a sugar or glucose, so typically a C6H12O6 molecule, and via the process of fermentation, which would typically take place at 37 degrees, so body temperature, in the process of yeast. So this is a biological process via an enzyme, and this would produce as a product of this reaction the ethanol molecule plus some carbon dioxide, and we would then need to balance up that equation by putting in a couple of 2's there. So we would have these two methods. Now both of them have pros and cons. Hydration would obviously be, because it's an industrial process, it's faster. It's a good process for making it quite quickly. It will also make it quite pure. So if you're wanting to make ethanol rapidly and in a relatively clean state, you would use hydration, whereas fermentation is obviously much slower and gives you an impure product. You have to generally purify the product at the end of it by separation of the yeast and the various starting materials that would have been there. But the downside to hydration is obviously that the ethene molecule is a finite resource, and so is obviously not seen as very green. It's not a green process in this because ethene would need to be manufactured from the alkanes, if you remember from our crude oil and our cracking processes. So it's obtained from crude oil, which means it's a finite resource, which is not going to be good for the world at large. Whereas fermentation takes sugar, which can be replanted, and so is a good thing because it's relatively quick to grow as well. So those plants can be fairly quickly restocked. Also, because this is a biological process, it's done at relatively benign temperatures. 37 degrees isn't particularly difficult to generate, and yeast is a fairly readily available enzyme. We have to be very careful at modifying those temperatures so that we don't denature that yeast and cause it to break down if we make it too hot, and likewise if we make it too cold it would be painfully slow in the process. But if we can keep it at 37 degrees, fermentation works relatively well and relatively cleanly. So we've got a couple of ways of making these alcohols, and so as we've done here, we've just introduced this third family. What we will do in the next clip is we will look at a fourth example of a family, that being the carboxylic acids, which will start to take the functional groups a little bit further and introduce an OH again, but we start to introduce a slightly different arrangement, and we can take our ethanol molecule and we can turn it into this next family along, which is a carboxylic acid, or specifically here, ethanoic acid. And if you have ever had or left a bottle of wine for too long and you hear the phrase, "it's been corked," this is where the ethanol has turned itself into a carboxylic acid, and specifically if this carboxylic acid here is ethanoic acid, or commonly known as vinegar. So sometimes when alcohol goes off, it smells of vinegar, and that's because of this oxidation process here. But we'll look at that in the next clip, and we'll look at the reactions of the alcohols in the production of carboxylic acids, and then those two work products which can themselves react together to produce esters. But we'll do that in the next one. So thank you for listening here, and I will see you in that next one along.